Hi, Contributor Snell. How are you? Can you help me?
I'm fine, bro. What do you need help with?
Actually, I need a tracker to find my hidden food. My memory is a disaster. Can you help me?
A tracker? You mean a hardware device or a software solution?
No, bro. I just need a simple Python code that I can run in Google Colab to store and find my food items. Can you help me?
Absolutely. Give me a moment. I'll write the code and create a video breakdown of how you can use it. Explanation section. Agenda, the food tracking algorithm. The goal of this project is to create a digital memory system for our squirrel friend. We are using a graph-based storage logic to map out the forest floor so no nut goes unfound. Overview of the solution. We are splitting the solution into two programs. CacheSaver.py, a logger that records the location, food type, and quantity into a persistent text file, nutdata.txt. NutFinder.py, a search engine that calculates the Euclidean distance between your current coordinates and all known cache sites to find the closest one. Workflow. Here is how the system operates in practice. Step 1. The input stage. The squirrel identifies a hideout, walks to the spot, and inputs the data: latitude, longitude, description. The script automatically pulls the last node ID, so he knows exactly where he left off. Step 2. The storage stage. The script saves this to a local text file. This file acts as our permanent, searchable database. Step 3. The search stage. When the squirrel gets hungry, he inputs his current GPS location. The code iterates through the database, calculates the proximity of every stored node, and returns the closest result. Deep dive. The code architecture. 1. The storage logic. Save nut data. This function is the memory keeper. Get last node ID. Before saving, we scan the nutdata.txt file. We use read lines to look at the very last line, extract the ID, and display it. This prevents the squirrel from overwriting existing data. Open nutdata.txt A. We use the A, append mode. Unlike write mode, which deletes everything, append simply adds the new information to the end of the file. This ensures our nut database grows over time without losing history. The formatting. We store data as a CSV, comma-separated values string. By saving it as ID, lat, lon, desk, food, quantity, we create a standardized structure that is extremely easy for other programs to read later. 2. The retrieval logic. Find closest nut. This is the search engine. It turns raw data into actionable intelligence. The loop. We open the file in R, read mode, and iterate through it line by line. Data parsing. We use .split comma to break the string apart. This converts the text line back into a list, allowing us to treat the latitude and longitude as mathematical numbers rather than just text. The distance calculation. We use the Euclidean Distance Formula. In geometry, this calculates the straight line distance between 2 points on a 2D plane. Comparison logic. We initialize min_dist as float INF, infinity. As we calculate the distance for each row, if a new distance is smaller than the previous min_dist, the code updates its target to the closer point. By the time it finishes the loop, it has identified the absolute closest node. Finally, we prioritize reliability. Try except blocks. In programming, if you try to open a file that doesn't exist, the system crashes. We use try except file not found error, so that if our squirrel friend hasn't hidden any food yet, the program simply gives a friendly message instead of showing an intimidating error screen. Input validation. Because we use float for latitude and longitude, the system forces the data to be numerical, ensuring the math calculations in the retrieval phase don't fail due to unexpected text. Check the entire storage logic code. These are the results of storage logic. Check the entire retrieval logic code. These are the results of retrieval logic. Now that the code is ready, you can run this right in Google Colab. Just copy the code blocks, hit play, and never lose a nut again. Don't forget to like and subscribe if you want to explore more content like this.